Alright, you are welcome back. Now this time around we are going to move down to product rule, that differential coefficient of the product. Now in product rule we have a formula for it, and the formula for product rule is dy ds equals to u dv dx then plus v du dx. So this is the formula for product rule, and there's a way to they got what this very word formula. Now the ability for you to identify the question, and if maybe you are given a question and whenever you have it two things multiplying each other, just know that you have to apply what product rule. If they are dividing each other, which is division, is quotient rule. Whenever it is dealing with power, is what function of what of a function. For example, if you have 2s plus 1 bracket 3s squared plus 3. Unlike this bracket is multiplying this bracket. So the type of rule to apply is known as a product rule. But if you are now having it like the 2s plus 1 all over 3s squared plus 3. You can see this one is dividing each other. The type of rule to apply is known as what? Quotient rule. But if you are having something like this 2s plus 1 raised to power what? 3. Unlike this one, this bracket is carrying what? A power. If it's dealing with power, it's known as a composite rule or function of a function. Okay, but if you have something like this, maybe you're having a square here, that means we are having how many rules here? 2 rules. Okay, this first one here is stating as function of a function. Everything here multiplying this make it what? A product rule. So the general rule in this place is going to be what? Product rule. But inside the product rule you have your what? Your composite what? Rule. All right, now first thing we are going to do, we are going to prove this formula first. Okay, once we are done proving that, then we can take some questions on that word product rule before we can move down to what? Quotient rule. All right, now how do we prove this formula? Very easy. All right, now we are making use of y equals to uv. Now using our first principle, I told you then that whenever you differentiate your y, okay, you have, don't forget what we have to prove is dy dx equals to u dv dx then plus v du dx. Okay, so have that in what? In mind. All right, so whenever you differentiate everything here, they are all alphabets. Whenever you differentiate your alphabet in first principle, this is written as y plus change in y, then equals to u, then plus change in u, then bracket v plus change in what? V. So what do I do here is to open up this word bracket. This is written as y plus change in y equals to u times v is written as uv. Then u times change in u is written as plus u change in u. Sorry, change in v. Then change in u times v is plus v change in u. Then change in u times change in v is written as change in u change in v. So from there, making change in y the surrogate of the formula, this y will move to the other side. It becomes change in y equals to uv plus u change in v plus v change in u, then plus change in u, then change in what? V minus y. This time around our y is written as uv. It's written as change in y equals to uv then plus u change in v plus v change in u, then plus change in u change in v minus uv. This time around uv minus uv can cancel out. So what you'll be left with, you'll be left with change in y then equals to u change in v plus v change in u, then plus change in u, then change in v. What we are looking for is dy dx. So what you do, it becomes dy dx, change in y, change in s, equals to u, you divide through by what? Change in x. So change in v over change in x, then plus v change in u over change in what? X, then plus change in u, then change in v, all over change in what? X. Then after that limit, your change in x approaches what? 0. So it becomes change in y, change in x, okay, equals to, so this is written as u change in v all over change in x plus v change in u all over change in s. What you are going to do is that you are going to limit everything here. You are going to neglect them or limit everything to be what? To be 0. So at the end of the day, your dy dx becomes u dv dx, then plus v du dx. So that's how they got what? This very what? Formula here. So this formula is known as what? Product rule. Okay, so we are going to take some questions using this very word formula. All right. Differentiate the following. Differentiate the following. WRTX. That is right in respect to x. It's certain that you are looking for dy dx. So number 1. So we have y equals to s cubed minus 2 4s plus 1. So we have to write in respect to x. Now, how do we go about that? Okay, the first thing you do, don't forget the formula is dy dx equals to u dv dx, then plus v du dx. Okay, the parameters we have here, we have u, we have dv dx, we have v, and we have du dx. First thing you do, you assign a variable to these two brackets. You can simply say between u and v, which are copied alphabetically, u comes first. You can say let u equals to s cubed minus 2, and let v equals to this other one, which is 4s plus 1. So you differentiate your u in respect to s, and you differentiate v in respect to s. So this is written as du ds equals to 3s squared. Then why this? We have dv ds equals to what? 4. Okay, I believe now we got the general rules for differentiation. So this time I can substitute everything here into this formula to get dy dx. Dy ds is equals to, what's our u? Our u is setting as s cubed minus 2, and dv ds is setting as 4. Then plus our v is everything here, which is 4x plus 1. Then du dx is setting as what? 3s squared. So from there, we use this 4 to open all the brackets. 4 times s cubed is 4s cubed. 4 times minus 2 is minus what? 8. Then plus 3s squared times 4 is sitting as what? 12s cubed. Then plus 3s squared. So here we can collect items based on power. So we have 4s cubed plus 12s cubed is sitting as 16s cubed. Then plus 3s squared. Then minus what? 8. So that is our final answer. Alright, so let's take more questions. Question number 2. So if we have y equals to 3s plus 4 bracket 2s squared plus 1. So we can say let u equals to 3s plus 4 and let v equals to 2s squared plus 1. So from there it becomes du dx. Whenever I differentiate 3s is sitting as 3. If you differentiate 4 is 0. 3 plus 4 is what? Is 3 plus 0 is what? Is 3. So from there we have dv dx. If you differentiate 2s squared is sitting as what? 4x. So from there the formula to get dy dx is equals to u dv dx then plus v du dx. So from there our u is sitting as 3s plus 4, then dv ds is sitting as 4x. Our v is sitting as 2s squared plus 1, then du dx is sitting as 3. So this time our 4s times 3 is sitting as 12s squared. 4s times 4 is sitting as what? 16x. Then plus 3 times 2 is sitting as 6s squared. 3 times 1 is sitting as 3. So collecting like terms based on power, we have square square. 12s squared plus 6s squared is sitting as 18s squared plus 16x plus 3. So that is our answer. So let's move down to the next. Alright, we're having y equals to 3 plus x bracket 4 minus x. Okay, so you can simply see let u equals to 3 plus x and let v equals to 4 minus x. So du ds is sitting, if you differentiate this is what? 1. Then dv ds is sitting at minus 1. So to get our dy ds is sitting as u dv dx then plus v du ds. So this time around our u is sitting as 3 plus x, dv ds is sitting as minus 1, then plus our v is sitting as 4 minus x, du ds sitting as 1. So from there minus 1 times 3 is sitting at minus 3 minus x, then plus 4 times 1 is sitting as 4 minus x. So from there minus 3 plus minus x minus s is minus 2x, then plus what? 1. Minus 3 plus 4 is sitting as 1. Minus s is sitting as minus 2x. Alright, let's take the last question. If we are having y equals to sine s cos x. Alright, you have 2 or 3 functions multiplying each other. So it's sitting as what? Product rule. So you can simply say let our u equals to sine x and let v equals to cos x. So what you are going to do, you differentiate your u with respect to s, so it becomes du dx equals to, if you differentiate sine s, you have cos x. So the next one, dv dx. If you differentiate cos x, you have minus sine x. So this time around, to get dy dx, don't forget it's u dv dx, then plus v du dx. So our u is sitting as sine x, dv ds is sitting as cos x, dv ds sitting as minus sine x, then plus our v is sitting as cos x. So du ds is sitting as what? Cos x. So from there, this is sitting as minus sine square x, then plus cos square x. If you rearrange, it's sitting as cos square x minus sine square x. And whenever you have cos square x minus sine square x, it's sitting as cos 2x. So that's strict function. So our final answer is sitting at cos 2 what? X. So either you leave your answer like this or you can leave it like this. They are both the same thing. Alright. So thank you very much. That's all for product rule. So we can move down to quotient rule. After quotient rule, move down to function of the function before we start taking the combination of all the what of the rules together. Alright.